Today we are graphing square root functions. Before we actually graph them, we're going to identify the transformations, which will help us graph them later. So first off, square root function is any function with a square root in it. Figure that. Now the transformation form, let's write that out. So we're going to be adding in some variables along with this. So it's going to look like k plus a times square root of x minus h, which if you've studied transformations before, you might have seen this k at the end here. It's here. It's kind of a long story why it's here on square root functions, but yeah, that's where it's placed. All right, so just a reminder of transformations. A causes a vertical stretch or reflection across the x-axis if it's negative. K causes a shift up or down. H, a shift left or right. So let's look at these functions and see what's going on. So here we have a minus 2 inside the square root. Well, H again causes a left or right shift. And remember, it's the opposite direction you might think. So H is actually 2 here, right? Because of the minus in the formula, H is actually positive 2. So that means this, the transformation, there's only one here, is right 2. This one would be left 2. It's the opposite. H is actually negative 2 here. Sometimes people say H lies, K tells the truth. Okay, so H is the opposite sign you might expect. Now you got to be really careful here. This one, we have it written out not quite in this order. Sometimes we do see k over here. Sometimes we see it before the square root. This is actually k. Now why is this not h? Well, because it's outside of the square root. See, the square root ends right there. So if it's outside the square root, it's being added or subtracted, that's going to be k. So this is actually a shift up by 2. All right, let's do some down here. Here we have a negative outside the square root. Well, that acts like multiplication of negative 1. So that means a is negative 1. Or in other words, there's a reflection over the x-axis. All right. The next one over, we don't quite have a variable in front of x. Sometimes you see transformation with a transformation form with a b here or 1 over b. I just don't want to make it too complicated here, so we're going to leave that out. But just know that if you have a negative on the inside of the square root, you actually have a reflection over the y-axis. All right, so we'll see some of that here. So if there's a negative inside, you have a reflection over the y-axis. All right, over here, a is equal to 2, and so that means this has a vertical stretch by a factor of 2. Okay. Let's see. Number 8, we would have a vertical compression by a factor of 2. To get the compression value, it's the reciprocal of this, right? So 2 over 1 or 2. So if it's less than 1, if this number is less than 1, because a is 1/2 here, you're going to have a vertical compression. All right, let's look at number 10 here. So this one we have a negative out front. A is negative 1/3. If a is negative, you're going to have a reflection across the x-axis. Or over, I said earlier, it doesn't matter. And then we also have a number that's, if we ignore the negative, it's less than 1. That means we have a vertical compression by the reciprocal, which is 3. All right. Why don't you guys pause this video and do the remaining problems that I skipped, and check back here for the answer. Okay, so on number 4, that was just down 2. Remember, this is k, and it's negative 2, so it's going to be a vertical shift down by 2. Number 9, here k is out front. That happens sometimes. This would be up 1, and then this is right 3. Remember, h lies there. Number 11, we have a negative a value, so we have a reflection over the x-axis, and then a, ignoring the negative, is 3, so vertical stretch by 3. And then here, k is negative 2, so it goes down 2, and then left 7. So let's actually graph some transformations of square root functions now. So let's think about the parent function here, which would just be the most simple square root function, just square root of x. What would be the key points? Let's write out its table here. So now, it wouldn't make sense to put in negative values here. If we put in negative values, we would have imaginary numbers, and you can't plot those on a real coordinate plane is what this thing is officially called, all right? It's the real coordinate plane. So they're all real numbers there. You can't plot imaginary numbers. There is an imaginary coordinate plane, but that is for a future math class. All right, so let's just, actually, I want to pick a different number there. I'm going to pick these numbers. So you might recognize these as the perfect squares. I picked those because those will come out to whole numbers. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. You might notice that we're only choosing the positive square root, while there is a negative square root also. I think I'll show why that is later. So when we talk about functions, the square root function, it's just defined as the positive square root. And again, we'll see more about that later when I graph one of these. Okay, so here are our key points. So we'll refer back to that when we graph these transformations. Okay, so let's think about how the parent function is getting transformed here. K is negative 2, so that means the graph gets shifted down 2, and then the minus 3 indicates that it gets shifted right 3. The 2 here indicates that there is a vertical stretch by a factor of 2. All right, so I'm going to go ahead and plot the parent function on this graph. I might only do this on this one, but it would be nice to see. So I'm going to take that table from up here, and I'm actually going to plot these points. So 0, 0, 1, 1, 4, 2, 9, 3, and that's all I can fit on here. I can't fit 16, 4. So I'm going to draw this not super dark because I'm going to draw the other transform function darker. All right, so there we have that. Back to why is this the positive square root here? Why isn't it a positive and negative square root? Well, if we had a positive and negative square root come out, what would happen is we would get actually a full curve here. In fact, it might remind you of a parabola. This is the inverse of x squared, so it looks very much like a parabola on its side. And if we had this part over here, would that be a function anymore? Would it pass the vertical line test? No, it wouldn't. So we have to define this as just being the positive square root. If it were both the positive and negative, it wouldn't be a function. All right, so that's why we just, we're talking about square root function, we just mean the positive square root. It's actually the same thing your calculator gives you. The calculator uses the positive square root function. That's why it only gives you a positive answer when you put in the square root of something. All right. So now let's apply this transformation to the parent graph. So we're going to take this point at 0, 0 and move it down 2 and then right 3 right there. And now there's a vertical stretch by 2, so instead of going over 1, up 1, I'm going to go over 1, up 2. Instead of going over 4, up 2, I'm going to go over 4 from this point, up 4. All right, and I don't think I can get another point because you would try to go over 9 and up whatever, but I can't go over 9. So this is really all I have here. Okay, so there's that. I shouldn't have drawn that little bit beyond it. It really ends right there. Okay, So now let's actually write the domain and range. I might label these. This is, we'll call this f of x and this g of x, just so it's clear. So that's the parent. This is the transformed function. All right, let's actually identify the domain and range. So the domain, again, we're doing of g of x here. The domain, well, it starts at an x value of 3, and it does actually hit 3, and that keeps going to the right forever. So it'd be 3 to infinity, like that, using interval notation. And then the range, well, the lowest value on it is -2. And then again, it goes up forever. It's not like heading straight up, but it is going to inch up forever. So that's what the range looks like. All right, let's do number 14 together too. That one's a little different. So we have let's identify our transformations. We have, it goes right to, up 1, and then this negative indicates a reflection over the y-axis. We saw that from up above. If you have what's inside the square root, if it's negative, that is going to cause a reflection over the y-axis. All right, so let's think about, now if it's easier, you can graph the parent on here and then transform it. I might just kind of use the one over here and think about it. So that point at 0, 0, well, that's going to shift right to and up 1. So right to up 1. There's no stretch here, there's just a reflection. So what I'll be doing, and you could actually just use, we don't always have the luxury of having the parent function in front of us, but you can create the reference points from just the parent function pretty quickly. Then we'll just use those 4. And so this tells us how much to go right and how much to go up. So and then we'll just have to think about how that changes based on any stretches or reflections. So, well, we already got 0, 0. Actually, you don't even have to think about that one. Then 1, 1, right 1, up 1. Well, instead, I'm going to go left 1, up 1. So it actually, this reflection of the y-axis causes these to become opposites. So let's graph the next point, 4, 2. So we're going to go left 4 because of the reflection. 1, 2, 3, 4, and up 2. And then left 9 and up 3. So left 9, up 3. All right. And I'm just going to turn my paper for a moment while I sketch this in. So we'll get something that looks like that. And let's do the domain and range. So domain would be, well, it's coming from -infinity. And then it's stopping at 2. And then the range, well, that is, the lowest point on it is 1 here. And then it's going to keep going up forever. There we go. You guys do numbers 15 and 16 on your own, and I'll be back with the answers here. Okay, so here is my answer for 15. There was just a couple translations here, down to left 7. So just the parent graph just gets moved by those amounts. And there's my domain and range. Number 16, this one had a lot going on. Up 3, right 4, vertical stretch of 2, reflection of the x-axis, since the minus here makes this 2 negative. Didn't see that before. So you have to move your point up 3, or your starting point up 3, right 4, and then you go over 1, down 2, 2 because of the stretch, down because of the reflection, and then over 4, down 4 for the same reasons. I see I didn't do domain and range here. Let me do that really quick. So domain goes from 4 to infinity. All right, starting at 4 here, going to infinity. Range is going to look a little different on this one. We have negative infinity because, again, bottom to top, right, for range. So negative infinity, and then it stops at 3 here. Okay. All right, let's identify some functions now. These are already graphed, and we just have to write their functions. So what might help is to see in front of us transformation form. So that looks like this. So I just have to identify what A, H, and K are, and I should be able to write my function. So looks like the starting point here has been moved right 1 up 3. So let me write that down. So that means that H is 1, K is 3. And then there's no stretch. You can kind of just tell where that 1, 1 point is, right? We have those reference points, or that one reference point of 1, 1 on the parent. We can see that this goes over 1, up 1. It matches this. So there's no stretch, and there's no reflection either. So this is it. So that just means A is 1, which you don't really need to write down the 1. So our function then is g of x equals 3 plus square root x minus 1. All right. Let's do one that's a little bit more interesting here. How about we will do number 19. All right, so looking at the starting point here, it's been moved left 3, up 5. So that means that H is negative 3, K is 5, and then it looks like the reference point, the first point to the right here, it's not over 1 up 1, it's over 1 down 3. So that just basically means that A is negative 3, or in other words, we have a reflection of the x-axis and a vertical stretch of 3. So we just plug those into our function. So K, we can see the formula up there, right? So 5, and then it's going to be minus 3 because of the negative 3 here, times the square root x plus 3, because when you put in a negative 3 in for h, you get the opposite sign. All right, you guys go ahead and try 18 and 20. Okay, so looking at 18, yeah, it was shifted left 2, down 1, and had a vertical stretch of 3. So we end up with this as our function. Number 20 was definitely different here, and this might have been a little bit of a challenge. We don't really have a place to, or variable to put our value for the reflection over the y-axis. There is one, but it's really, it kind of gets a little confusing. So, but know that if you have a reflection over the y-axis, if the graph is heading to the left instead of to the right like it normally does, that's going to cause a negative sign inside the square root. And then it was shifted down by 1. The starting point was down 1, so we have this negative 1 value for k. All right, that is that.